All right. First, if you guys don't know, my name's Kevin Isaac. I work for the corporate quality. I also manage the commercial test lab where you guys send product in on a monthly basis. I've been with GAF going on 7 years now. About the first 4 years of my existence with GAF, I handled more modified bitumen than I did TPO and injection molding. Reason being that modified bitumen needed a lot more help than you guys did. So I spent a lot of time in Savannah, Georgia, Arkadelphia, Arkansas, and out in Stockton, California. Sounds like good places to go. I couldn't really tell you. I know about the plant, the hotel, and the airport. That's about it. So if we would, if you guys don't mind, can we kind of go around the room so I kind of get a sense of my audience here? I don't know who wants to start. You want to start?
Sure. Tim York, I work in the commercial test lab under Kevin. I do a lot of the testing on all the products you guys send in.
Josh Glass on the injection molding co-op.
Okay.
I'm Deidre Sanders, I'm the financial analyst here. Joey McLaughlin, I am the finance manager. Tia.
Let's do it.
Baron Anderson, I'm the GA specialist here.
Amanda Federoff, I'm the plant where I am the TPO.
Jake Hill, I'm the process engineer for TPO.
James Reinbold, I'm a TPO co-op under Jake.
Kevin Marks, TPO production supervisor.
Eric Gentleman, quality technician.
Kimberly Toller, quality technician.
A couple co-ops in here. All right. You guys both Penn State?
No.
Just me.
Good man. All right, so this is normally a 2-day thing. We used to break it up in 2-hour sessions, but the way it laid out for you guys, and we did this in Gainesville too, we'll try to hit this all in one day. It's scheduled for 4 hours, and we try to break each session up in some classroom, some hands-on stuff, right? So in the morning session, I'll go through some stuff up there. We'll watch a video on installation. I don't know if any of you guys have been through the CARE training before, or have actually welded and seen your product actually being installed. And then we'll actually go into the CARE training room and everybody get a chance to run the robot welder, kind of get a sense of why we harp on certain attributes like lay flat, banana curl, why the weld lines are so important, that kind of thing. And then once we do that, everybody does their welds, we'll go back to the lab and we'll see who had the best weld. We'll put everybody's ply adhesion samples on the Instron. And then we'll talk through some of the other testing that they do in the lab that you guys may not be aware of, right? They don't just test the TPO, they test the polymers coming in. I know a lot of that's probably COA review, but we have had some instances with, well, you guys had the biggest problem with, you don't call them stringers, what do you call them? Angel hairs coming in from some of the suppliers, Basel. And then Ineos, we bounced some rail cars out of Mount Vernon, I know, for melt flow issues. So I don't know if you guys have had that same thing here or not. And then we'll walk through the workmanship guide. You guys actually own it, but I think everybody got together and kind of created that.
Yeah, Cumming had one for injection molding, and we upped that when we started IM, and then when we started up TPO, we're like, we should have this for TPO, and then all my counterparts helped me build it.
Right.
And we still add to it this day.
We kind of turned it into a PowerPoint slide, or Tim did, where I show the issue up there, because before I was just showing the document itself, right? So if you've ever seen the document, it tells you what the issue is, and then where to go look and what to change on the line. Well, I didn't realize I was giving everybody the answer. I'd show them the thing, and I said, all right, well, how do you fix that? And they just read off of it, so we changed that around a little bit. All right, so like I said, first, as far as installation goes, you guys are making 10 foot long, 10 foot wide most of the time. I know you guys have the capability to do 12 foot wide, but 10 foot wide, 100 foot long rolls, right? And when you get your hands on the welder, you're gonna kind of understand why we can only allow a 1/2 inch of what we call banana curl, race tracking. Do you guys use banana curl as
Banana curl.
the term here? Because that guy on the roof has got to run that welder 100 foot, right? And if it's got any kind of, curve to it, if it doesn't lay flat, if there's any kind of issue with the sheet, they're up there fighting that, right? And those guys are getting paid by the square, so they want to get that product down as fast as possible.
For those of you that are more upfront, do you guys know what banana curl is? No. So like when you roll out the roll, it should look like this, but if it goes like this, it's over 100 feet, it's going out like a banana coming back in. This is his first time doing it for staff people, so yeah.
Oh yeah, that's what I should, so this is geared towards the operator, so there's might be some stuff that I think you might know that, you may not. Like, well, for instance, do you know why there's 2 weld lines on your product?
I didn't know it was too complex.
So in your domestic product, there's a red and a blue line on there. You put it on with a big pin. I don't know if anybody orders the big pins. You go through a
I
bunch
knew
of
about
them.
that. I just didn't know they were called weld lines.
Yeah, they're called weld lines.
A lot of times we call them pin lines since it's been doing it.
Yeah. So it's pretty low tech the way we put it on, right? It's with a big pin. But it's very important to the installation of our product. So one is about 3 inches in. So if your product is what we call, not mechanically fastened, fully adhered, thank you. Fully adhered, meaning that they actually spray glue down on the ISO board and then roll your product on it and stick it to it, right? So if we're doing that, then we only gotta come over 3 inches, and that's where we make our weld to make a watertight seal. Now there's other installations that's called mechanically fastened, where they actually take a screw and a big washer and they drive it down through there. You guys also have your little triangles that you put on there for, fastener location. And that's to, tell the installers how to install our product and ensure that they do it correctly. But if you do that, when you put that hole in there, you're driving a hole, you just put a hole in a brand new sheet, right? So it's no longer watertight. So you gotta come 3 inches past that and make the weld, and then you make a watertight seal. So when you guys get your hands on the welder, you guys will see the 2 different lines on there. That's why they're there. There's also a date code on there. That's required by ASTM that we all have to put a date code to identify when the product was made, where it was made, that kind of thing. Yeah, so talking about some of the common defects, like I said, the banana curl, the hooking is definitely a problem, especially when you're going for 100 feet. Now, we're only gonna weld maybe 3 or 4 feet, but it'll definitely give you a sense of what the challenges are on the roof when they start to install our product. So they also have me talking through the RMA process for the operators. Is everybody familiar with our RMA process?
Return material authorization. But not when we do it for raw materials, when the customer's returning the rolls.
So luckily, I don't say luckily, but in your group, in the commercial group, there have been 0 RMAs for customer complaints since last August. Now, compare that to the shingle world, they get them every day, right? I mean, they're putting these things on roofs, on somebody's home. The days of the $5,000 roof are over. They're spending $15,000, $20,000 to put a roof on their house, so they want it to be pristine. So there are a lot of issues.
We do a lot of RMAs, but they're not, it's just they ordered the wrong thing, they ordered too much. Shipping just handles that, and there's no quality aspect to it.
Right.
Although sometimes the rolls are damaged, so they have us inspect them, and then we charge the customer and dispose of them. The only RMA we had was those fleece rolls, where we argued with the customer and sales paid them, but then they took it off the claims because the customer was full of crap.
Well, and that's the other thing, because last year you had some for detail membrane. It was the same issue, right? They said that it wouldn't weld. They wanted to send so many rolls back here, and it hit the quality issue. And so we sent it around to weld it, and it welded just fine. And there was no partial roll. So to me, if they were having issues, then they should have a partial roll where they had those issues from. We got full rolls back. So it ended up being that they ordered 25 rolls, they only need like 18 to do the job or something. And that's where sales kind of sticks it to you at times, because when they're out there on the front line, they're wanting to make the issue go away, right? And so they'll tell the customer, yeah, we'll take it back, there's a problem, and then on the back end, you guys got to deal with it. Well, accounting especially, you got to, make sure it goes in the right buckets and that kind of stuff. So here's some of the issues that we can't get RMAs back, like you was saying. They either can't accept it, warehouse limitations, they requested the wrong material, or they no longer need it. Customer care entered the wrong material. They entered the wrong location to ship to. They're closed, which that seems highly unlikely, but, and then they either received damaged or defective material, which is, let me turn that off, which is nothing that, you guys do. And then, they received the wrong material because the truck went to the wrong place or something like that, right? I know, does, Standard Logistics haul a lot of your loads now? Or
Yes.
They doing pretty good for you guys?
From what I understand, they're way more expensive than using someone else, but we have to use our own fleet. They have a supervisor that sits there, and we do have a base of them that are stationed out here.
Okay. Well, one thing, so they started doing the same thing in the shingle plant. So the commercial test lab is located inside the Mount Vernon shingle plant. There's also a TPO plant in Mount Vernon, it's just up the hill from us. So we see a lot of the Standard Logistics. And one of the things that kind of got to me and kind of illustrates where you guys did everything right at the plant level, but our hauler might have screwed up, right? So Valdosta, I don't know, I know you've been there, I know you've been there. You've been there too? All right. So they were getting ready to make their first shipment, right? And those of you guys that have met Daniel, the plant manager there, you know that he's gonna be very well prepared, right? So he had that truck loaded 3 days in advance from when it had to leave. Standard Logistics sends the first driver in. He doesn't have hazmat endorsement. He can't pull the load because of the glue and the seam glue and stuff like that. Second guy comes in, same deal. Third guy comes in, he's got all the endorsements, but instead of hooking onto the load, he drives to the back of the lot, takes his nap, his 10-hour downtime, right? Gets up the next day, hooks onto the load, starts to the customer, gets about halfway there and realizes that he doesn't have his wallet. So instead of going and making his delivery, he turns around, goes back to Valdosta, finds it in the parking lot, gets back on the road, and the load was 3 hours late getting to the customer, their very first shipment. But they had it loaded in three days in advance. So, there's issues like that. I know a lot of your stuff doesn't go to distribution, but there's also rolls that get damaged in distribution. They are not as diligent on storing our material as we would like them to be. And, that's something that our group, when I say our group, the quality group has started to take on. We hired an individual named Meldon Collins. He's now our director of supplier quality. He's pulled a pretty good team together, and they've revamped their supplier audit, and they're also working on a distribution audit to where we'll actually go into the distributors and do the audit, make sure that they're storing our product correctly and that kind of thing. So like I said, sometimes you guys will get an RMA back and the roll will have a big gouge in it and it didn't leave here like that. But, unfortunately it happens in transit. So that would be some of the stuff that kind of trip on our RMA. If there is a complaint, the way it works is product will be sent to a claims lab in Parsippany, and they will test the product. Now, they're very good at testing shingle, they're pretty good at testing mod bit, not very good at testing your product. So,
Worse than Rich Fence.
oh yeah, our bridge fence. So those will come to our lab, and then we will do the investigation because we test your product all the time, right? And we'll determine whether it's good or bad. And like I said, in well over a year, we have not had any customer complaints out of any of the commercial plants. I don't know about ISO. I guess that's included as commercial as well. Which kind of surprised me because I know they kind of lump my bid into commercial, and I know they've had some issues here and there, but nothing. You guys have had nothing like that. So then once they determine whether it's a good or a bad claim, there's an individual named Mawad Sadiq. I don't know if you've ever heard of Mawad. He's kind of over the claims lab. And then he will make a determination if we're going to pay him, give him more material, what we're going to do to make the situation right. Like I said, you guys are definitely not in that category. So any questions on the RMA, the claims process, that kind of thing? All right. Well, our next thing is to get in there and start welding some product. If you guys are willing to do that. Now, if anybody's not comfortable running the welder, I will say that welder runs at 1148 degrees, right? We do have safety precautions in place, but if you're not comfortable, that's fine. You know, we can just skip you, you'll get the gist of it with everybody else doing the welding, that kind of thing. So we gotta do a pre-job brief.
Yes, there is a JSA for it, so we should probably run through the JSA and then do the pre-job brief and pull it up.
Can I get to it on the drive, or?
I don't know, it might be on a drive you don't have access to.
Might be the local drive.
Well, it's not our local drive, it's our AODocs library.
All right, so you're not at Penn State, where you at?
RIT, Rochester Institute of Technology.
Okay. Rochester, New York?
That's new.
You from New York?
I'm from Maryland.
Oh, okay.
Does this pre-job brief count towards my safety?
It does count towards your safety thing for all you people who never do your thing until the last minute.
Hey, now, that was harsh, it's true, but it was harsh.
If y'all do it, yeah. That'd be cool.
Nobody's come to the last day, on the last day.
Last day or two of the month, and, hey, we need to do this, and well, it's been done, so no.
Fire, there's a fire. I would say that from suburbs.
Oh, Kim, I'm not gonna touch your melt flow indexer or your microscope or anything, I'm just gonna talk about it. All right? I won't touch your Instron if you don't, you know, you guys can run that too.
Alright, you guys ready to walk through the JSA? Inspect the overall condition of your working area, perform general housekeeping and organize your work area to eliminate slip and trip hazards and ensure good work ergonomics. Keep hands and arms away from the welding nozzle. So the first step is turn on the welder and allow it to heat up to 1148. Next step, position TPO on the floor to be welded. Sprains and strains. Use proper ergonomics when positioning TPO on the floor. Position welder onto the material. Slip, trip, or fall, sprains and strains, burns. Identify the path that the welder will make and be sure the cord is positioned out of the welder's path. Use the leverage of the handle to position onto the material. Do not try lifting. Keep hands and arms away from the welding nozzle. Release the welding nozzle and slide it under the TPO. Burns, sprains, and strains. Keep hands and arms away from the nozzle. Use good ergonomics. Walk with the robot, guiding it until the end of the sheet. Slip, trip, or fall, burns. Make sure the cord is positioned out of your walking path and the path of the robot. Keep hands and arms away from the welding nozzle. Tilt the welding nozzle back up and in the locked position. Burns, sprains, and strains. Keep hands and arms away from the welding nozzle. Use good ergonomics. Use wire brush to clean melted material off the nozzle on both sides. Burns. Make sure only the wire brush makes contact. Wear heat-resistant gloves. Move the robot welder out of the way and start the cool-down cycle. Slip, trip, or fall, sprains and strains, burns. Make sure that the cord is positioned out of your way. Use the leverage of the handle to position the robot welder. Do not try lifting. Once again, and if anybody doesn't remember this, then I'm pour on you. Keep your hands and arms away from the welding nozzle for the 80th time. Alright.
I did skip a side, we should, I don't know why it's not showing up better, but there's a little installation video here. I don't know if you guys know who Dave and Wally are. They ever come here? There you guys. So these are two characters, and you'll get a sense of them a little bit here. They go around and install our product, and then they make these videos for different folks. I'm pretty sure they come up with a new layout, what we can call it, fit and form.
The foreman's flow, they cover that, yeah.
So the first time I grabbed this, I grabbed one of our competitors' videos. So.
I can't believe our company has ads on our videos.
I'm Dave. And I'm Wally, and it's hot. It is. Well, you guys been seeing our videos of our little project we got going on here. We're finally to the stage where we're gonna start installing membrane. But you may notice we're wearing booties. You guys in the audience may chuckle at that. You gotta remember we've been tearing off a nasty pitch roof. I mean, it's been hot, it's dirty. You didn't pack one of their shoes. I didn't. No, so it's your fault. Yeah, so, is booties necessary? No. but it's gonna keep that membrane cleaner when we're kicking it out. You don't have to wear booties, but I'm telling you, they sound stupid. These things are cheap, but it's gonna save you a little time. You don't have to clean so much. So, we're gonna lay this roof out. How are we gonna lay this roof out there?
Well, I think we're gonna start here in the drain with a 5-footer, because we're tapering this way, well, actually, we're tapering all ways. We're gonna start, center this on the drain, pretty much, run from, wall to the edge out there, and then we're gonna go to the left and to the right, where they're gonna take over the crew that's doing the tear off.
Tear off over there.
Right, they'll take off, or take over and go that way. Now, the reason we did this, of course, is because the deck's going this way. Mechanically attached, we have to hit the top of the flue.
Run our sheets this way.
Right, that's why we're running our sheets this way. I mean, you could run them this way because that is longer, but because of the deck, we're going perpendicular to the deck.
So, we're looking at this roof. How many half sheets do we really have to have?
Well, if you wanted to do a half sheet, you would do out there, back, out, and back.
A lot of mess around.
A lot of messing around, so I think we're gonna do fingers maybe?
Do one half sheet, run fingers.
Right,
We'll talk about that a little more as we get started.
perfect. Yep.
Alright, so up on the roof, those guys gotta manhandle these rolls. There is no mechanically
Okay, we're gonna take this
assist.
5-foot roll and center of this drain. Rather than trying, we're gonna take it to a one. That's our specification under a plan frame. Rather than run the membrane, cut the hole, and try and get this tube, squeeze it in there. Anybody that's ever busted water block know how messy it is. We're gonna do it prior to installing the membrane. Actually, this is our flex seal, I thought it was our water block. Flex seal, one water block, this is our spec, one full tube per drain. Now the trick's gonna be, somebody doesn't walk in it. Which, I'm sure you guys have been on a roof, you know that's virtually impossible, but this is gonna be covered up. We'll put something around here so nobody actually gets it.
So those are mechanically fast tonight. They're driving the screw right down through your feet and they're all proud of it.
We're not gonna put clamping on right now, we'll come back in a little bit, just so nobody walks in this area, it's kind of old. I get the center of this drain, so I'm gonna tidy it up.
Alright, so that's the robot welder you guys can see, right? This little, I call it a pizza cutter, the little guide wheel there. When you make that overlap, that has to run right on that seam, and that's what keeps your welder straight. That's what keeps you, giving you a straight weld.
So the settings I put on the robot was 10 feet a minute, about 900 degrees. This machine will run, I believe, well, 1148 is the maximum temperature, and I believe this V2 will run around 30 feet a minute. You will never, you say this again, you will never weld TPO on fast. It's, you gotta remember, I've got this big cord I'm trying to drag with me, I'm gonna try to keep this thing straight. I've got deflections in the deck, as you can see right here, that we're gonna have to come back and patch in. But how I arrived at these temperatures was, there's a formula I was taught years ago. You take the ambient temperature, whatever it is, it's about 80 degrees, so I divided that by 10, gives me 8. I added 2 feet a minute to that, gives me 10 feet a minute. Gets me in the ballpark, okay? You don't have to stay there, but you gotta have a baseline. And I did test welds earlier. What I did, I set this up at 10 feet a minute. I started at 600 degrees and I did it well. I bumped it up 100 degrees and I did another weld, but I didn't touch my speed. What I did, I ran those temperatures till I maxed this machine out from 600 degrees to 1148. And I went back and did my test pulls, and I set the machine up in the middle, which gave me about 10 feet a minute, right around about 900 degrees. So that's where when we test welds, that's how we arrived at the settings on this machine.
So you see how the guy come past that mechanically fast to be able to make that watertight.
What you do now is at the end of these sheets, we're going to put fingers.
saw a video of it come up in the middle, I guess. Now, Chino is the hand welding expert. I am not, so we will not be doing any hand welding.
Just by an inch. Now he's gonna put 5 seam plates in here, 5 fasteners. Now he's gonna use his fasteners, fasten it down, and then we're going to strip that in with our 8-inch flashing strip, which is a reinforced product. What this does, now I have fasteners every 5 feet out here at the edge of the roof, where the wind is, when it gets first. You can also do fingers with Rhinobond. So we put the Rhinobond plates in first, lay the sheet over top, and come back and zap it in.
So right now, I'm cleaning the membrane. Very important to clean it, just because I cut it, you know what I mean? It's not too dirty, it's a brand new roll that just came out, so I would just use water for this. There's no need for, the PPO cleaner or just plain old water to work. So guys, as you saw, I just welded this by hand. Kinda took me a while. I highly recommend when you guys are doing this to use the robot. Use the robot to weld your fingers as well. It saves you some time. Now, the only reason I'm doing it by hand, our generator is being used somewhere else. I want why not finish this up? So I'm using the hand welder, but always better use the welder to help you guys out with the job. So now what we're gonna be doing here, we're gonna end up doing the wall flashing, and we have like a steel beam on the side of on the bend, so we're gonna move the flashing 7 inches on the flat. So one of the tricks that I was taught by Dave, Wally, and Mark was when your guys are there, you mark your 7 inches. When you come here, you measure 14 inches. So when you mark your 14 inches, once again, we have a 7-inch on the flat. So what we're gonna do is go back and put the edge of the seam right here where those 14 inches went. Just crease it out.
So he's talking about what we call parapet wall, meaning it goes up, right? So you gotta hit the flat and then you gotta hit the vertical with the same product.
Once we're done, this is actually gonna help the TPO do an L shape. So we're not fighting it. Because if you don't crease it, instead of having that nice little L shape, it's gonna come out and it's gonna blow out right at the transition. So we really, really wanna square this up, because as you can see, it's gonna stay nice and flat, and this crease ups is out. So this is a cool trick. I recommend everybody using it, and you're not trying to fight to try to get the TPO tight to the transition.
Well, we got through another one. Barely. We're wrapping this one up here in Maine. We've done tear off, we've
Ate some pitch.
ate some pitch,
Ironed some pitch.
6 inches of tear off, something like that. We got all the TPO on our end, tapered systems on, everything's buttoned up, ready to go for the contractor to kick off tomorrow. It's up to him to finish this job. It's about 5:30 or 6 o'clock here in Maine, and I think we're just about ready to go. What do you think?
I believe so.
Anything you want to add?
It's been a long day, ready to go back to work and get some rest.
I heard that.
Let's go.
So that's Dave and Wally, like I said, they're characters.
Energy providers don't really know about this trick that he has is practical.
Like I said, Chino is the hand welding expert. We had some issue last year with a dark bronze product that the contractor claimed they couldn't get it to weld, right? Especially the detail membrane to the reinforced membrane. And normally, when they have issue welding, like he was saying, you raise the temperature of welder, right? Well, with the dark bronze, you actually have to go down in temperature, because as that sun puts that UV energy into the sheet, that dark bronze really soaks it up and it raises the temperature of the sheet. So you gotta kind of mitigate that. He talks about his test welds. He'll do that in the morning, and then depending on how long the job goes on, they may have to do some more test welds later in the afternoon, again, because that sun has been putting heat into that sheet. Now I'll show you how they do their test welds. We'll pull your welds apart and what they're looking for to ensure that they get a good weld. Now we will be running the robot welder 12 feet a minute, 1148 degrees. That's how we do it across all the quality. That way we're all doing it the same way. The reason we don't do the hand welding is because there's so much variation in it, right? Like there's 4 of us in our lab, and if all 4 of us were to hand weld, we'd all get different results because, I'm not very good at it. Like I said, it takes a 2-hand operation. I'm left-handed, so my right hand's not that good. You guys are probably the opposite, So it's definitely a balancing act there. So, all right, you guys ready? All right, we got to do a pre-job brief.
Yes. So we pulled the JSA, so you guys know what steps we're taking, and you know what countermeasures there are. So what are our countermeasures? It's number 1 thing we said.
PPE.
What PPE are we wearing?
Our keepers and gloves. Safety glasses.
Heat gloves, safety glasses. What was what?
Steel toe shoes.
I think it'd be close toe should be all right. Most of us have steel toe. What was one thing I said 8 times?
Don't touch the heating part.
Keep your hands and arms away from the nozzle.
Be extra careful when you're using the wire brush. Clean that off. That's the most likely place you're gonna get against.
I had an operator in Gainesville get down and almost reach and touch the nozzle one night there. Luckily, like I said, it's almost 1200 degrees, so he recognized when he got close to it, he probably shouldn't touch it. Even though we went through this exact same scenario,
Quick question, in the video when they creased that sheet to do up the wall, so we had a return or a complaint about creases in the sheet when they rolled it out, and then in the conversation about that, it's been brought up that when they crease it sometimes, the glue, over time, that it cracks where they creased it. Have we ever seen that? If that's the common practice, they're creasing it to do that, have we seen cracks or have complaints about that over time?
we have, and about that same time that was going on, they were actually redoing some schools in Mount Vernon, so I was able to get up on the roof. And another practice that they do that they don't tell you about is when they go to overlap those sheets, sometimes they'll fold that top sheet back and they'll take the buckets of adhesive or something heavy and sit it down through there. Warmer weather, we don't have any issue with it. Cold, depending on how cold, we could have some problems from time to time. But I saw what they were doing up there. Again, it was nothing that we did. That's not how we tell them to install our product. And that's why we put those lines on there. That's why we put the fastener marks on there, because we want them to install our product correctly. If we were to not give them the weld lines and tell them to come in 12 inches or 6 inches, they would have to snap a chalk line. And how many contractors are going to do it the correct way, right? If they fudge a little bit, then that means they may not have to use an extra sheet. They can save some money. Same things with the fasteners. If they don't put it every 6 or 12 inches, they can save some money. But that's what we find most of the time. If there ever is a complaint about, especially TPO product not working, it's almost always an installation issue. Very, very rarely is it something you guys created, a bad product that leaves here. Because you guys tested extensively here. And we'll go through that more when we get in the lab, and then we'll talk about the testing that we do on top of what you guys do at the commercial test lab. I say we, Tim and Jim and Dylan, not me. We safe? We good?
We're good.
All right.
Does everyone have their glasses, or there's some glasses in there we can grab too? And I wrote all your names down and I'll give you your